Greetings and welcome to this tutorial on error and exception handling using throw, rethrow, and try-catch activities inside of UiPath Studio. We will continue as we have throughout all the previous activity and lessons that we have accomplished. Begin with another new project as a process. So clicking on process here, we want to call this project error handling. Again, go ahead and stay with the normal naming convention for our folder path location wherever you have been saving your projects to date. We'll go ahead and continue down that same path. And for our description, I'll say working with error and exception handling using try-catch, throw, and rethrow activities. Once you have that, simply hit create. So as the project's building, the concept behind a try-catch block, it's a scenario in which we are expecting code that we have a certain likelihood or an expectation that the code may not always be able to be successfully executed. And what we do is we put that code that we believe will not necessarily execute correctly into what we call a try condition. We have the code try to execute, and if that code fails, we then catch the error or what we call the exception that's currently handling in the system at the current moment in time. And then we try to do some additional logic or processing, or ultimately send a notification back to our logs most commonly, and allow the system to continue to process without having a hard stop, critically terminating type error condition from happening. So we'll walk through an example of how to play these various situations out, try to bring a bit more context to exactly what it is I'm describing right here. So as always, simply go into our open main workflow. In the activity that we want to bring in right off the bat, it's simply called try-catch. So I'm looking for, I did a quick search for try-catch, and we're going to bring this try-catch activity over into our canvas here. And you'll notice this is exactly what I was describing just a moment ago. We've got a block right here. Notice it says try. It says drop activity. We can also say drop activities, so it allows us to put a small sequence of activities inside here. This is the spot in which we have that we're going to place code that we believe has the potential to cause some type of error. A process is unable to complete a particular activity. It's going to vary obviously from one automation to the next as to why code may potentially fail. We'll get into an example of where maybe we're going to check a condition, and if that condition doesn't work, or for some reason we can't compute a condition, depending on what's on the user interface that we're trying to screen scrape, or do some type of computation against, at that rate we need to be able to throw an error. We can't do whatever it is we need to do in order to make this particular record as part of our automation run successfully. We'll run through an example here momentarily where maybe a selector, and we're going to talk about selectors in our very next activity, but it's the eyes and ears, really more the eyes, not necessarily the ears, in which UiPath is able to see the screens that we're trying to navigate through, or screen scrape, or data extract from, etc. What if the selector is not available? So what I mean by that, what if a specific value on a screen that we need to capture isn't readily available to us? We need to be able to skip over that record, move on to the next. So you're kind of hearing at this point even a bit of a commercial for, yet again, ReFramework. Try-catch is one of the fundamental premises upon which the ReFramework that we're going to get to here in a couple of activities is all about. So let's bring this thing to life. But before we do that, this idea real quick, The idea here, again, try being that we're going to put code in here that we believe has the potential to fail. Something is not able to be processed the way that is intended or desired and within our automation. When an error does occur in that situation, and our code is in this try block, when an error or an exception happens, that's where the execution immediately skips over any of the code that's left in the try block and comes right down into this, what we call our catch block. And you'll see here it says add a new catch. We're going to get into the details of that momentarily as well. But this is where we actually capture the error that has occurred and try to handle it in some way or another. So hence the error handling. We want to handle the error to where it doesn't, totally terminate our automation from running successfully, albeit the one record that we're processing, we're going to have to be able to circumvent and skip over and move on to the next. And then kind of a bit of a abnormality to what we've been describing, we then have this finally block as a part of the try catch activity. The finally block, what we'll describe here is regardless if an error or an exception has occurred or not. So if the code up here was able to successfully run, great, we don't get into the catch block. It's simply the code as it completes the try block will go into the finally block and execute any activities that we may have placed. And here you'll notice it says drop activities here. On the same notion, if we're in a try block and an error and exception situation develops, and again, the code will go into whatever catch we put into play here. The code will attempt to mitigate or lessen the severity of the impact of the error exception that has occurred. As it leaves the catch block, it will also go into this finally code. So the finally block down here simply to state after the code executes through a try, and if it needs to go into a catch, the finally block will always execute every single time, regardless if an error situation or an exception situation has occurred or not. So this code is guaranteed to always execute on either side of the coin if an error and exception has occurred. So to try to bring this into a bit more hands-on approach here, let's go ahead and bring in a multiple assign activity inside of our try block. And what we're going to do is similar to what we've done earlier when we were working on the selection decision structures. Let's go ahead and define two new variables here called int number1 as the integer. Set the scope here. I don't know how much we've talked about scope, but what this needs to be is the setting it. Notice right now it's at the try level here. I want to set this at the sequence level. What we're talking about with scope here is the level in which the variable is known. So in case of this one here, int number1, which I want to clean this up a little bit, int number1, when it said only known in the scope of try catch, what it is saying is that variable is only known inside of here. If we had code that needed int number1 outside of the try catch, it would fail. It would not know what it's talking about. So changing sequence to this higher level is ensuring that int number1 is known in the entire XAML file here. We'll do the same thing, int number2. And notice it's already on sequence, and the reason being is, notice when I created this variable, I have my scope, if you will, set where I had sequence highlighted, so it was going to create this variable at the broader level. But I always try to set the scope at the higher level here, ensuring that the variables aren't lost in the process. But you may have particular situations in your individual automations as to where the scope needs to be limited down to just a certain area within your single XAML file. So we've got int number1, int number2. I've got my multiple assign. Hopefully you have an idea where I'm going here. And this is going to be assigning int number1 to, let's just say 2. Say int number2 and have it assigned to 8. And then the next behavior that our next activity that we need to bring in is a if activity. We need to check to see how int number1 compares to int number2. So inside our if activity, the condition here, I want to have int number1 is less than int number2. We're simply asking the question, is the value in our variable int number 1 less than the value that we have in the variable int number 2. And obviously at this rate, 2 is less than 8 if we look at it, so we know we're going to hit the then condition here, because 2 is indeed less than 8. So just to bring some demonstration or context to this, let's go ahead and bring a right line activity into here, and we will simply say int number 1 is less than int number 2. Simply stating a fact based on the logic that we have. Here's where we're going to begin to have a bit of fun with the use of try-catch blocks. So trying to role play out this very generic example, let's say we have a situation in which we're checking a value against another value as part of our automation. Maybe it's even a situation in which a value doesn't exist on a screen that we were attempting to automate against, that we need that value to be able to successfully process this record. That's where having this check here to say, does value exist? In this case, is 2 less than 8? Some type of check to say, is the expected value on the screen here? If that expected value is on the screen, go ahead and go down the then path and automate whatever it is we're trying to automate. But what you're going to find in your automations is you're going to go against the same screen, multiple different records. 98% of the time, all the data is exactly the way in pristine state, exactly the way you expect it to be. But there's this other 2% of the records. I'm being very fictitious with the numbers here, but maybe it's 5% of the records. But you're going to eventually come across the screen. This is a guaranteed fact that will happen to each and every one of us. You're going to come across the screen on a record, and for some reason the format of that screen doesn't jive with the other 95 or 99% of the records that we've been trying to process. You can't process this record because the value we expect on the screen isn't there for one reason or another. That's where we get into this idea of throwing an error. So looking in our list of activities, you'll see there is a throw activity. I want to bring this into the else condition. Notice the little blue dot shows up. We need to define what this throw is about. This idea is throwing an error. We're raising an error. We can't compute this record for one reason or another. In this case, in our generic example, if int number 1 is greater than or equal to int number 2, we need to be able to throw an exception, raise an exception, cause UiPath to go into an error state is what we're talking about. And then we're going to learn how we trap or catch this error, and then obviously handle it to where it is no longer an issue. But first things first, we have to tell UiPath we have an error. So we do that via this activity known as throw. We are going to throw an error is how we describe this. Notice on the throw property, there's nothing within the immediate UI that we're able to specify any values, but notice in the properties, there is a exception here. Notice it is expecting a type, data type here of an exception. And the way we do this is type in the word new, and we are going to type in this case, we're going to raise a application exception. So I started typing application. You notice it's prompting me to go for application exception. We're going to go ahead and use this one, but just to demonstrate, you could also raise a business rule exception. So I'm starting to type in business. This is another type of an exception that we will commonly discuss when we get to ReFramework, but just mentioning it here for demonstration purposes. But again, for what we're going to do, we're going to go ahead and create an application exception. We will talk about the difference between business rule and application rule exceptions in our conversation later when we get into talking specifically about the ReFramework, because they both play two independent roles, specifically when we get to that topic. But here, new application exception is how we are specifying the exception property here. And once we type in new application exception, if you do a open parenthesis, it says message as string. So we all know string is expecting, text. What type of error are we dealing with here is what we're trying to go after. And in this case, our specific situation here, the error that we are going to raise is we're going to say int number 1 is greater than or equal to int number 2 in the quote. What is the error? That's all we're trying to specify right here. What is this error about? So it's a descriptive message as to what the problem is. So generically in our automation, we're being very specific to say, you know, in this case, we had a number that's bigger than a value and one that's bigger than a value that or is equal to 2. We can't process this record in our role play that we're talking about here. Throw an error here, raise an error to have happen. So, taking that same example that we talked about a moment ago, the idea that if we're on an unexpected screen, the value that we're needing for automation on this particular record, isn't readily available. We can't do anything with it. That's where we might say application exception, unexpected value, on screen, or unexpected screen detected, unable to process record, something like that. A meaningful description is what we're going for right here inside of our string quote as we raise exception. If we would have done business rule exception, the same rule applies. Open parenthesis, what is the reason why we are raising the error? Simply click OK here. And you'll notice we still have a blue dot here. It says catch are finally expected for the try catch activity. We need to now be able to capture the error. We need to be able to more specifically catch the error. What is it that has happened in our automation, and how do we capture or catch that error? And that is done through the catch activity down below. And this is kind of like an accordion. You have to unfold these guys. So notice right here it says add new catch. So if we click on here, you'll notice, you even saw with the new application exception, business rule exception, there are a lot of various types of errors that we can catch. And notice there's even a browse for types. We're going to come back to here before we conclude this activity. But the type of error that we raised a new application exception error. And an application exception error is of a generic type called system.exception. We are raising a system level exception error. So I'm going to click here, system exception. And as I do that, as soon as I click off of it, you'll notice the exception block has exception on the right. And that's again from that system.exception that we just did. We can now bring activities into our exception here to be able to describe what it is or be able to handle the particular problem. Again, we could have multiple activities in here in a sequence as well. For simple demonstration perspective or purposes alone, we're simply going to bring a write line activity in and say exception caught we'll say error message is, and then here we're able to say exception dot message. I'll put this in the bigger window so you can see everything that we've got here. Get the right window here. Here we go. So in the text here, same thing, the text activity. Hey, we had an exception. We caught it. We're at this point, we are successfully handling the error that has occurred in our try block is what we're talking about here. And we're simply saying the error message is, in this exception.message, what we had up above when we threw the error, we had the new application exception, and then in the quotes, that text that we put in the quotes comes back out right here, the exception message. What is the error that we are dealing with right here? So I'm going to go ahead and cancel here. You'll notice our blue dot has gone away. We are now in a state in which we can run our automation. We're expecting a potential error to occur, and an error may not necessarily occur. In this case, if we look at our logic, 2 is indeed less than 8, so we're going to hit the true path here. We should get a int number 1 is less than int number 2 scenario. So if we run our automation, we should not get an error. This is happy code. Everything's good to go. And as it completes here, we've got int number 1 is less than int number 2. Let's play this out the other way. Let's make int number 1, greater than. So now we're going to hit our error state. If we run our automation here, when we're in debug mode, it handles a little bit differently. In debug mode, it will actually stop at the point that we are throwing the error. So notice int number 1 is indeed greater than int number 2. So we end up on the false side of our if condition. And notice we're waiting on our throw event, and it's telling us we're throwing an error. Int number 1 is greater than or equal to int number 2. If we say to continue to step into, again, we're going to slowly walk through the details here. You will see it now gets into the catch block. So the right line activity is going to generate here. I want to step into, there's the error. Notice it says exception caught, error messages, int number 1 is greater than int number 2. That's again from our message that we had before. I'm going to go ahead and finish the automation here. To try to demonstrate this maybe a bit cleaner, we're going to finally use the run activity. So what if our automation was running, in full out execution mode? If we run the same code, notice it's running right now in the background. As it comes back, notice there are no really hard errors here. Notice we got a nice clean exception. An exception happened, but notice our automation had no major issues. There's no red ugly text showing up on the screen. In the debug mode, it gives us that so we can actually see the path in which the code is going down. It's detecting there was the error. So it allows us as a developer to see it. But this, what I just did by doing it in run mode, this is how our automations are going to run in regular everyday use. Non-development, purposes. Actual execution mode is going to be in run mode. So notice here, everything's happening. No significant errors or problems. You don't need to follow along with me here, but to demonstrate how problematic errors can be, I want to throw an error outside of my try-catch block. Just purely from a demonstration perspective. You don't have to follow along. This is purely demo purposes. I want to throw another application exception here and say, major error has occurred. Error is not being caught. Notice this is outside of the try-catch. And I can throw an error like this. This would be more reminiscent of, a system level problem has happened in, the way we built some of our logic. I'm forcing UiPath to go into an error state here that lives outside of a try-catch. So what does this look like in regular run mode? If I run this, watch what happens to our automation. I get this actual pop-up error here. Notice when we had this in the try-catch, this pop-up box did not show up. Notice it says runtime execution error. Source is coming from the throw activity, and look at the message. It's exactly what it is that I just typed a moment ago. Major error has occurred, and this error is not being caught. If this was running server-side, to where we were running this in an unattended fashion, no human intervention, we got the task scheduled, it kicks off without any, involvement of a human user. That's our long-term goal of building these automations, is to allow them to run freely and independently of any human involvement. If this was running server-side and this error pops up, look what's now happened to our automation. It has completely failed, and it's stuck. It's waiting for the user to click the OK button here. This could be any type of error, inside of UiPath Studio. This one obviously being a custom-generated throw error. But anytime we believe there's code that has a potential to fail, we need to ensure that we throw it in a try-catch block. So this exact scenario that's currently on the screen does not generate and raise itself as a potential problem in our automation that causes our actual automation to fail and to lock up and not continue to process further records downstream. So again, that's why this little example that I just demonstrated here is exactly why we have and use try-catch activities. And couple other final details to bring to head. Notice we talked about the finally block down here. Remember, it executes regardless if an error or an exception has occurred or not. So either way we go, this code will always execute if try was successful, or if it ultimately was caught by an error and exception occurring. To simply demonstrate this, bring a right line activity into finally and say finally reached, just so we can demonstrate this code always executes either way we go. So recall, we still are in an error state. I deleted that throw that was outside the try catch here. Going back into the try, like I said, it kind of acts like an accordion. It's a big of a goofy interface here. But when I was in finally, notice finally is now wrapped up. I clicked on try so I can see my situation here. So notice 10 is still greater than 8. So we will still hit our error state here. We'll have our thrown error. I'm going to go ahead and do run again. Recall this is so I don't have to deal with the little pop-up error when I'm in debug mode. But notice there's the caught error and then finally reached. So it's demonstrating here that we're still in the finally, the code is executing when within the finally condition here, or I should say finally state. Just to demonstrate it the other way around, let's do 2 and 8. So back to our original. We know this is a successful run. So we will not be caught on an error, but to demonstrate, we still want to see the code in our finally block down here. So again, I want to go ahead and go into regular run mode again. When I do this, you'll see that int number 1 is indeed less than int number 2. So this is our happy path. Everything's going good. But notice the finally reached scenario has played itself out. So the next thing that I want to demonstrate is the ability for us to have multiple exception types down here. So notice it has the option here of saying add new catch. So how do we cause a new type of error to raise? What I want to do, this is kind of a bit of a forecast into our next lesson that we're going to talk about dealing with selectors, but to demonstrate this in a bit more of a practical use case here, I'm going to bring up calculator. So go ahead and open up Windows Calculator, and what we're going to do is play around with selectors that may not be there. So again, this would be a really common use case in an automation. Again, going with the idea of an expected value is not on the screen that we're trying to automate against, but it's a required value from the screen that we need for our automation to be able to successfully process. This would actually be a potential use case for using this try-catch activity that I'm getting ready to demonstrate here. But in order to do this, I need to introduce a brief little look-see into the use of selectors. So this would be one of the first activities that we bring in that utilizes a notion known as selectors, which again, it's the eyes of UiPath. And when we get to our next activity, we'll dig into selectors in a lot more depth and detail, but this is purely for a demonstration perspective. So in our activities, go ahead and follow along with me here. Bring in a click activity. So in this case, element mouse and click. And let's bring this in right above, so make sure you have your try expanded here to where you can see the multiple assign. I want to bring the click activity right above the multiple assign. This could go underneath the multiple assign and the if. I'm just choosing to bring it up here at the very top. But the placement in this case really doesn't matter for what it is that we're trying to do here. Notice with the click activity, it's saying indicate on screen. And indicate on screen in this case, go ahead and click here, and you'll notice UiPath kind of goes out of the way, and now UiPath is in this kind of what I call vision mode. It's showing you as the developer, what can I see? I being UiPath. And you'll notice in this case, as I hover over any of the command buttons here, it's the different buttons that UiPath can manipulate, or utilize or see, be able to click a button. If I hover over the numbers here, you can actually see the values that are being displayed to the end user. Being able to click some of the expander menus, etc. We're not going to go into depth here. When we get to our conversation on selectors, we'll dig into additional detail there. But in this case, let's pick any of the numbers. It doesn't matter which number you pick. I'm going to randomly pick the number 5 here. If I click here, what you're going to see is it's going to give you a little screenshot of what it is with a red box around the 5. This is trying to tell us the UiPath is being instructed to click the number 5. And if I run my automation here, what you're going to see the calculator do is you're going to see UiPath actually click whichever button you selected. In my case, 5. There is the button 5 being clicked. I'm going to, just for clean purposes, I'm going to hit the clear button on my own here. But the good news is you saw UiPath was able to come out and click the button number 5 and then termination of code. The logs that we're seeing here, it's still the same ones that we had before. We did not disable any of that code in number 1 lesson. At number 2, finally reached, and it was able to successfully click the button. One thing to tweak really quickly here, inside of our click button 5, on the target side here, change this timeout in milliseconds to 3,000. 3,000 meaning 3 seconds. Without getting into the weeds of this, this is purely saying how long is UiPath going to wait to see if this value is on the screen. And the reason I shorten this is, you notice if we did not, it would sit here for 30 seconds and wait to see if this is, if in this case the number 5 is available to be clicked on, yes or no. And what I want to demonstrate here is what I shared a moment ago, this idea, what if a selector is not available to UiPath? So to demonstrate this in kind of simplistic terms, simply close calculator. Notice the button number 5 is not on the screen anymore. UiPath is going to get into an error state. It can't find the selector, as it's called. It can't find button number 5 that we've asked it to click on. So if we go into run mode, actually I want to do debug here, sorry. What you're going to have happen after 3 seconds, notice it's counting, notice here we've got an error. This is a system generated error. This is not by us saying throw. This is coming from the system now. The system saying, it's very technically written, but the system right here is saying, I can't find button number 5. It's not availably clicked on. I'm in an error here. So we need to have the ability to catch this error. You notice if I continue to let this thing run, it's going to say exception caught. And the reason why is this is a application level exception. So the current error state is picking up on it here. So that's why we have the clean error. Remember, this is from what we saw. It cleanly caught the error. So if I actually do this in regular run mode, the error is going to cleanly be caught, but it's caught in our more generic application level exception. Notice code successfully ran. There's a slightly better approach that we can take here. We can be more specific as to what type of exception errors we're trying to catch. So to do this, again, more from a demonstration point of view, we've got the ability to say add a new catch here. You'll notice though, we're trying to capture an error that's talking about selector not found. And it's not in our list here. This is where we have to be able to go into this browse for types. So notice I've gone in right underneath, I said add a new exception. In this case, browse for types. This is very similar or reminiscent to what we've seen when we're adding new variables that the data type isn't readily available in the dropdown. Same type of concept applies here. In this case, I want to look for selector, and notice just in a matter of a few keys, I get this selector not found exception. And I want to click on here and say OK. So now you see UiPath course selector not found. If I kind of click off to the side, you'll notice it now says selector not found as an exception. And what I want to do is display here in a simple write line activity. Simply say calculator app is not open. End quote. Here, I'll blow this up a little bit so we can see it. Calculator app is not open. We can, in the same notion, we can continue to say exception dot message here. And click OK. So now, if we run through that scenario, So we've added a new exception. Calculator app is not found. I am going to do a full out run here. Now we're getting, the purpose here is we're getting into a very explicit type message here. You notice in my error, it now says calculator app is not open. Notice it's no longer in our other exception. So this is where we can delineate out different exception types based on what it is that we're expecting the automation to do. And obviously from a coding perspective, the one thing I'm not demonstrating too well here is we can actually begin to put additional code in here, maybe to right size the ship, actually fix the error. Maybe, the value, if it's not in this particular spot, maybe we can check another spot and be able to pull the value from there. So you can add additional code in here that, you might be able to handle the situation a certain way, just given that it's not in the normal or the expected typical flow of how things are going. So these are the major, activities that go on from a try, catch, throw, and rethrow perspective. I shouldn't say rethrow, we have not talked about that, and that's where I'm getting ready to go. But this whole idea of try, catch, and throw, it's kind of hard with the demonstration that we've got here to really hone in on this concept of rethrow. But allow me to try to articulate this the best that I can. Notice we've got an activity called rethrow. And what I'm going to do in the exception block of our original exception here, I want to bring this rethrow activity in and place it underneath the right line here. And notice the sequence window is now kind of set itself. Again, going with the notion to describe, you can have multiple activities here. The case in point here with rethrow, the one thing that I haven't really clearly articulated to this point, when we get into a catch block, when the code leaves the catch block, remember we saw, when it's done, it goes into the finally state and executes code there. In that transition from the catch to the finally, the error state is, quote, cleared. The error has been resolved. The error goes away. So the fact that we've caught the error, kind of one of the hidden things that's going on behind the scenes from a UiPath point of view, is that error has been cleared or resolved. The error is no longer there. UiPath is not in an error state any longer. The reason I say rethrow is a difficult one to describe here, it's difficult in the notion that I'm in a single try-catch block here. Imagine, and we will, it's not even imagine, when we get to our ReFramework conversations, we're going to find this notion of try-catch blocks living inside of another try-catch block, so being nested inside of another try-catch block. When we get to ReFramework, we're going to find that these try-catch blocks live in multiple XAML files. So going back to our last activity talking about working with multiple XAML files, this idea of rethrow in that notion is talking about how we're able to allow the error state that has been caught here to live on outside of this specific try-catch block. So I'm talking this one here, the one that raised the error originally. This idea of having rethrow allows us to send the error state to the next try-catch block that might exist, to sending it one level higher. When we get to ReFramework, that one level higher again might even be in another XAML file, from the one that called the XAML file that we're currently in which the error state has raised. So long story short, to recap, when we're in a try-catch block and an error has occurred or an exception has occurred, if we don't have a try-catch block, you saw in the demonstration I had a moment ago, we actually get a pop-up error, a fatal type error. We've now locked the system up, it's unable to process. That's why we use a try-catch, to try to cleanly capture an error state so it doesn't totally negatively impact their automation. And at that rate, when we catch the error, as the error state's caught, we can put all the code that we desire and need, try to right size the ship back up. If for some reason on the far other reach we need that error to persist or linger on, outside of the current try-catch the error had occurred in, that's where we're able to bring in a rethrow activity. you'll notice there's nothing for me from a property's point of view to be too concerned about with this point. It's simply telling UiPath, allow the error to linger on. If we did not have a rethrow here at the exit, of the catch activity, the catch phase, UiPath is more or less saying the error is no longer existing. We've handled it. We've cleaned it up. Business as usual. The system is back to a normal state again. Simply go down, execute the code in the finally, and then obviously if you've got any additional code that might live underneath try catch, it's part of the sequence. Just continue on down the road. Again, a lot of this, we're demonstrating it at a very high level here. When we get into ReFramework, you're going to continue to see the use of try catch. That's why this activity is so critical, of just understanding the basic premises and purposes as to how a try catch, what its purpose is, and the nature in which it actually functions and operates. And that concludes our conversation as it pertains to error exception handling using throw and rethrow and try catch activities inside of UiPath Studio.